Here is a very important question which have been asked in previous test papers. Let us see how to solve such a question. We need to convert complex number z equals to I minus 1 divided by cos pi by 3 plus I sin pi by 3 to a polar form. You can always pause the video, answer the question, and then look into my suggestions. Now, when I say polar form, it means what? It means I want to write z equals to r times cos of theta plus I sine of theta, right? So that's the polar form we are interested in writing. So basically, we need to find the magnitude r and the argument theta. So these are the two things which we need to calculate. Now, how should we go about? So let's think about writing this in numbers, pi by 3, reminding you of the triangle, which can give you the values directly for pi by 3. The sides are 1, 2, and square root 3, correct? Now, we can write the complex number given to us, z, as equal to I minus 1 over cos pi by 3 is half, right? So I'll write this as half, plus I sine pi by 3 square root 3 over 2. Now this could be simplified. We could take 2 in the numerator, I minus 1 over 1 plus square root 3i. So let this be so. So that is the complex number which we have. Now to simplify, we should actually find the complex number with multiplying by its conjugate. So we get 2 I minus 1 over 1 plus I square root 3. Well, multiply and divide by 1 minus I square root 3. So what do you get? Well, in the numerator, we'll get 2 times I minus 1 times 1 minus I square root 3. And in the denominator, it will be their squares, difference of squares. So 1 minus I squared 3. So I square is negative 1. So it becomes positive 1. We can now multiply these terms. Well, that is 4. So let me write this as I minus 1 times 1 minus I square root 3 over 2, right? So since this number is 4, 2 will go 4 times. Let's expand this now. So in the numerator, we have I minus I square makes it plus square root 3. Multiplying by minus 1 gives us minus 1 and plus I square root 3 over 2. Now combine the like terms. So the real part here is square root 3 minus 1 over 2 plus the imaginary part, which is square root 3 plus 1 over 2. So that becomes the complex number. To find the magnitude, which will be r for us, so r will be equal to the magnitude of this complex number, which will be a square plus b square square root. So it will be square root of square root 3 minus 1 over 2 whole square plus square root 3 plus 1 over 2 whole square root. So that is equal to, so this is 4. We get 4 in the denominator. And in the numerator, a square plus b square, these terms will cancel out, right? So what we get here is, let's expand this. So what you get here is 3 minus 2 times square root 3 plus 1. And here you get plus 3 plus 2 square root 3 plus 1, correct? So that gives you square root of 3 plus 3, 6, 7, and 1, 8. These two cancel. So we get square root of 8 over 4, which is square root of 2. So from here, we found that the magnitude is basically equals to r, which is square root of 2. Now, on a fresh page, let's find out the argument theta. So we can write the complex number z as equal to square root 3 minus 1 over 2 plus I square root 3 plus 1 over 2. Now, to find the argument, we can say tan of theta is basically equal to the ratio of imaginary part to the real part of z, right? So that gives you the ratio of imaginary part is square root 3 plus 1 over 2 divided by square root 3 minus 1 over 2, which is square root 3 plus 1 over square root 3 minus 1. Well, this is positive, so we can drop the absolute values, they cancel away. Okay, now see the trick involved now. So we can actually divide both numerator and denominator by square root 3. So divide both numerator and denominator by square root 3. So then you get tan theta equals to 1 plus 1 over square root 3 over 1 minus 1 over square root 3. Now, in terms of tan, how can you write 1? Well, let's look into our special triangles once again. So we have these two special triangles. For pi by 3, we wrote 1, 2, and square root 3, right? We're looking into 1 over square root 3. So 1 over square root 3 will be pi by 6, correct? So I could replace the numerator with, and 1, we are reminded of pi by 4 triangle. So 1 could be replaced by tan pi by 4, right? Plus tan pi by 6. Now, if you recall, we have tan A plus B formula. Let me write down here. What is tan of A plus B equals to? Now, tan of A plus B is tan A plus tan B over 1 minus tan A tan. Correct? So I got that numerator part correct. Now in the denominator, I have to get something like this. I have 1 minus. So we could think about multiplying this by the number 1, right? So that 1 will be tan of pi by 4, correct? So we could write the denominator as 1 minus tan of pi by 4 times tan of pi by 6. Doesn't make sense to you, right? Since tan pi by 4 is 1, right? So we could always multiply and then write like this. But that really helps us to give the result. And so the angle basically is sum of pi by 4 and pi by 6. You get the idea. So that is how we could get it, right? Now taking common denominators, I could write this as tan of 12 is my denominator. So I'll multiply this by 3 and that by 2. So this becomes tan of 5 pi by 12. Correct? So comparing, we get theta equals to 5 pi by 12. Sorry, 5 pi by 12. Correct? So we got the argument theta also. Earlier we found that r was how much? Square root 2, right? So earlier we found that r was square root 2. And therefore now we can write that the complex number z can be written as square root 2 cos of 5 pi by 12 plus I sine 5 pi by 12. So that becomes in polar form. Is that clear to you, right? So that is how we can get our answer.